Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting question: a square minus a cube equal to 12. We need to solve this equation for h, so if you have your solution, your answer, your approach, you can write your solution in the comments below and then we will check our answer. So it will be really interesting to check our answers in the end of the video. So first of all, let's subtract 12 from both sides. As a result, we're going to write this 12 on the left side, but with the negative sign. Okay, so this is our first step. So what do we have? A square minus a cube and minus 12 equal to 0. Right now, what do we have? We have a square and we have the third power. And right now, let's try to expand, let's try to express this 12. For example, in our case, the best way to express it is to express this 12 as 8 plus 4. Okay, so we can express this as 8 plus 4. And a lot of students might be asking, why can we express this as 8 plus 4, not like 6 plus 6 or like 7 plus 5 or something like that? And here is my answer. 8, this is a great value, this is a great number, because we can write this 8 as 2 cubed. This 4 can be written as 2 square, and this expression helps us a lot because then we can group this third power with this a cube, the second power with this a to the second power. So right now let's see what will happen. So first of all, as I said before, we're going to write instead of this 12 8 plus 4. So we have a square minus a cube minus, instead of 12 we're going to write 8 plus 4. Okay, so we have 8 plus 4 and equal to 0. Right now let's open our parentheses. Let's do this. So we have a square minus a cube minus 8 and minus 4 equal to 0. Okay, so I really hope you understand it. Right now, as I said before, we're gonna express this 8 as 2 cube and this 4 as 2 square. So let's do this. So as a result, we have a square minus a cube minus 2 cube and minus 2 square. So we change nothing. Basically, if we go back through these lines, we're gonna have the same expression as in the beginning. So we change nothing. Right now we have a square right here. So I just want to underline it with these 2 square, and we have a cube and we have minus 2 cube. So we can easily group it. First of all, I'm gonna write it in parentheses. So we have a square minus 2 square from here. Okay, so we have a square minus 2 square from here. Yeah, the next thing, what do we have? We're gonna have minus a cube plus 2 cube. Okay, a cube plus 2 cube plus 2 cube. Right now we need to remember a few classic and the most popular algebra formulas, because these have a difference of squares. So I just want to write this formula right here on the bottom. So we have, for example, x square minus y square. So the difference of two squares, how can we express this? So we can write it as x plus y, yeah, x plus y, and x times x minus y. This is a basic formula. I think that 99% of students know this formula. And the second formula, like a little bit difficult, because we have a cube plus 2 cube. So we're gonna have like x cube. Let's write it like that: x cube plus y cube. Let's write it like that. We can easily write it as x plus y. According to basic school knowledge, this is our basic formula. This is not a higher math formula. This is basic school formula. And in another parenthesis, we're gonna have x square minus xy and plus y square. Okay, so I really hope you understand it. Two formulas, and right now we're gonna apply this formula right here: difference of squares and the sum of two cubes. So difference of squares, we're gonna apply. We're gonna have like a minus 2a plus 2, or a plus 2, a minus 2, doesn't matter. In our case, let's use, for example, a minus 2, a plus 2 right here. Yeah. And we're gonna have minus. These are the sum of two cubes. As a result, what do we have? We have a plus 2, and in another parenthesis we're gonna have a square minus 2a and plus 4 equal to 0. Okay, so I really hope you understand it. Right now, let's look closely. We have a long expression, but a plus 2 right here and a plus 2 right here, so we can easily factor it as a common. So let's do this right now. So we have a plus 2 in the first parenthesis, so we have a plus 2 in the first parenthesis, and in the second one I'm gonna leave it with parentheses. So a minus 2 right here, a minus 2, because a lot of students can solve this part with the mistake. So right now we're gonna leave parentheses right here and minus this with parentheses. So don't skip this part, just keep these parentheses all the time. So a square minus 2a and plus 4, because a lot of students try to open parentheses real quick, they add real quick, but if you solve this question with the two additional lines, you can't solve this question with the mistake. So this is a really great moment. Okay, so we have a plus 2 right here, a plus 2, And in another parenthesis, as I said before, a lot of students might be skipping this part. They try to solve this question quickly. But if you look closely, okay, this parenthesis right here, right now, without parentheses, a minus 2, in right here without parentheses, but we need to change all the sign to the opposite one. So we have a minus 2 minus a square plus 2a and minus 4. And right now, of course, you can't solve this question with mistake, because right here we can easily add it. We can easily add 2a and 2a. We have 3a minus 2 minus 4. We have minus 6. So right now we can easily write a plus 2 in the beginning, yeah? And this parenthesis, first of all, minus a square in the beginning, so minus a square. The next thing, we're going to have a plus 2a. We have plus 3a. And the next thing, we're going to have minus 2 minus 4. We have minus 6 equal to 0. And right now with these two additional lines, you solve this question correctly, because a lot of students mix this subtraction sign, make this addition sign, and they forget about negative sign, positive sign, and they solve this question wrong, because this equation need to have a correct sign, okay? So as a result, what do we have? We have a plus 2 on the left side. Right here, I just want to multiply this parenthesis by minus 1, because we don't need this negative sign right here. We prefer all the time positive sign in the beginning. So let's multiply both sides by minus 1. And of course, this parenthesis we're going to multiply by minus 1, this 0 by minus 1, but it changed nothing. So we still have 0 on the right side. But this parenthesis, we're going to change all the sign to the opposite one, a square minus 3a and plus 6 equal to 0. And right now we can easily be proud of ourselves that we solved this question. We solved this question correctly. We factor it correctly. We expand it in terms of like parentheses. And right now we can easily solve this part with two parentheses. Of course, product of two parentheses is equal to 0 when the first parenthesis is equal to 0, a plus 2 equal to 0, or the second parenthesis is equal to 0. We have a square minus 3a plus 6 is equal to 0. Right now, let's solve real quick the first one. So a plus 2 equal to 0. From here, a first equal to minus 2. We're going to check this a first equal to minus 2 a little bit later. Right now, let's solve this quadratic equation. This is a basic quadratic equation, so don't be scared about it. We can easily solve this question with the basic method, with the method of coefficients. Of course, we can easily write that a equal to 1, yeah, b equal to minus 3, and c equal to 6. So right now let's solve this quadratic equation in terms of basic method of coefficients. First of all, I prefer finding a discriminant. Okay, we have discriminant equal to b square minus 4ac, so this is equal to b, so we have minus 3, so b square minus 4 times 1 times 6. Okay, so this is our discriminant equal to 9 minus, we have 24, so our discriminant is negative, we have minus 15, so it means that right here in this branch we're gonna have like two complex roots. So let's find it. So we have a second and a third. This one is real number root, but right here a second and a third, we're gonna have like two complex roots. So we have minus b plus minus square root of discriminant and all over to a. We know everything about it. We know coefficients, we know discriminant. So let's plug in each of these elements into this spot. So we have minus b minus 3 plus minus square root of discriminant, so square root of minus 15, and all over, we're going to divide all of this by 2a, so 2 times 1. Right now, a few manipulations, because we can simplify this. We can easily, instead of this minus 3, we can write 3, yeah, plus minus. This square root of minus 15, we can easily express as square root of minus 1 times 15. We can easily express this in terms of like multiplication all over 2. Right now, square root of a product, so when you have square root of, for example, x times y, you can easily write it as square root of x times square root of y. This is basic square root property, extremely important, extremely powerful property, yeah? So we have 3 plus minus square root of, we can easily split it, square root of minus 1 times square root of 15 and all over 2. But why do we split it? Because square root of minus 1 equal to I, and we really need this imaginary unit, because basically discriminant is negative, so it means that we have imaginary unit, we have our I complex root, yeah? So square root of minus 1 equal to I, yeah? And as a result, we have 3 plus minus I square root of 15, I square root of 15, all over 2. Yeah, I really hope you understand. And a lot of students split it in terms of like real part and imaginary part. What I mean right now, they divide our numerator by 2, so we have 3/2 plus minus I square root of 15 over 2. And right here you can easily see the real part and imaginary part. So this is up to you, how can you prefer. This is, of course, this is our answer. This is maybe the classic one when you split it like real part and imaginary part. Okay, so let's write our final answer right here because I don't have enough space on the right side, so let's write on the left side. A second, let's go with the plus sign, so we have 3/2 plus I square root of 15 over 2. This is our a second. And a third equal to, we have 3/2 minus ai square root of 15 over 2. So these two roots are complex root, okay? These two roots are complex root. Yeah, and this one is a real number root. Let's check real quick our a first equal to 1. First of all, our equation looks like that. So in the beginning we had a square minus a cube equal to 12. So for a equal to minus 2, let's see what will happen. So for x, not like x, we have a, yeah, we have a equal to minus 2. Okay, so what do we have as a result? I don't have enough space, so let's solve this right here. We have minus 2 square minus minus 2 cube equal to 12. Okay, a lot of powers, a lot of negative sign, but minus 2 square equal to 4. Yeah, we have even power. Yeah, and minus 2 cube, this is odd power, so it means that we still have a negative sign. As a result, with this negative we have positive, so plus 2 cube equal to 8. So everything is great. When x or like a doesn't matter, what do you have? For example, you have x square minus x cube equal to 12, or a square minus x cube equal to 12. So in that case, a equal to minus 2. So we solved this question. I really hope you understand my solution. So this is not the hard question, but you know, a classic method is with the Cardano formulas. When you solve this question with the Cardano formulas, because it's a cubic equation. But in some cases, for example, you have 12, you have like maybe 2. So this 12 can be written as 2 cube plus 2 square. And this is extremely important exactly in this case, because we can easily group cubes and squares, and we can easily factor it. But for example, you have a right here, you have 13, so there's no way how can you solve this question with that logic, because you can, of course, 13 you can easily split by 8 plus 5, but you can't group it. So this is a solution exactly for that case. Maybe there are a lot of cases right here, maybe like 2, when a square minus x cube equal to 2, so you can express this as 1 cube plus 1 square. Yeah, in this case, and when right here we have 2, so we can easily express it like that. But I really hope you understand my solution. So it's not that hard with basic manipulations, with basic algebra formulas. We can easily solve it. So I really hope you understand my solution. You can also write your notes, write your thoughts in the comments below. Write your question, what do you think about it, and of course, maybe you have something to ask, like what formula, how do we solve this this part, how can we find each of these coefficients. You know, a lot of questions you can easily ask in the comments below, and then we'll discuss a little bit about it, because this is a great question. So thank you everyone for watching, thank you for your time, take care of yourself, have a great day, and see you in the next videos.